So, hello everyone, and welcome to the 10th Fenix Infrastructure webinar. Today, we're welcoming our speaker, Javier Bartolomé from the Barcelona Supercomputing Center, or BSC, who will be talking to us today about the ICEI resources at BSC. I am Nicoleta Chiapidu from BSC. I'm the dissemination leader of the ICEI Fenix project. And just a few words for the structure of our webinar today. After my very short introduction now, I will give the floor to Javier to do his presentation. And there will be a Q&A slot right after his presentation for any of you that would like to ask any questions or make any comment. You will be able to write your questions in the chat during Javier's presentation or during the Q&A slot. Or during the Q&A, you can also click on raise hand and I can unmute you so you can ask your question out loud if you prefer. So this is our structure, our agenda for today. And before we go ahead with Javier's presentation, just to let you know that the webinar is being recorded and we're planning to upload the full recording and the presentation slides on the Fenix website afterwards. So you will be able to have a look at these resources next week. And I will also present just a couple of slides in the end to let you know about our website and useful links for you. So I think that's it from my side. Javier, if you want to begin, you can start sharing your screen.
Okay. So let me start sharing the screen. I hope that you can see the...
Yes, we can see the slides.
Perfect.
And now it's presentation mode. Okay.
Okay, so thank you everyone for coming to this webinar. Two main remarks, initial remarks. Right now I'm inside one of the data centers because we had one issue with one of the systems. So maybe you are hearing that I'm shouting a little, but it's because I have some background noise. In case that I cannot hear any question, please try to repeat the question. Just have in mind that. And also thank to all the systems to have the courage to assist to a webinar on a Friday afternoon. So it's very, I'm very happy that you came to this. So the webinar will be devoted to the introduction of the ICEI resources that we will be providing through Fenix AI at BSC, okay? So this is more or less the agenda of the webinar that we prepared. First of all is a table summary with all the resources, all the values and numbers, and then a spread out of the different services of ICEI and the different infrastructures that I will be covering and providing the different services. From the cluster that will be providing the scalable computing services and virtual machine services, the interactive computing cluster service, and then the storage in the infrastructure that we have, the active storage and the archive one. And finally, we will have a little of explanation on how to access all these Fenix resources and a lot of question of answers, okay? So let's proceed with the initial part, which is like the big summary numbers of the whole resources that BSC will be contributing through ICEI call. So, and I think that you can see my mouse, and it's more or less how the webinar will be also be structured. So you will see the details of each of these components or clusters. So we will start with the Node cluster, which will be doing the scalable and the VM services. It's 84 nodes devoted to ICEI. And these are the proportional that will be reached through the HBP calls and the praise calls. The interactive computing cluster, which is formed with 3 nodes, and all of them are devoted to ICEI. So these are the computation on calculating a 90% of the availability of the node. So we are taking out the availability on maintenance in this accounting. And then we have the 2 types of storages. One, which is the active storage, which is the one that it's mounted in all the HPC clusters with resources of 70 terabytes. And also we have what we call the Agora storage, which is the archive storage, which we will providing 10 petabytes of storage, which is, we will see the details later, is a combined storage with disk and tape, okay? Just to, as Nicoletta said, if you have any question, I will try, I'm monitoring the chat, or if not at the end, we can have the question and answers session. So if we start with the first infrastructure that is covering the services of scalable computing and the virtual machine services, it's a cluster that we call Nord 3, and it's based on the hardware of previous Mare Nostrum 3 supercomputer. Nord 3, it's composed of 9 iDataplex compute racks, in which each of the compute racks, we have 84 nodes, and we have the different switches that connects the different nodes to the different networks. So in this case, per each computer rack, we have 4 Mellanox switches that connects to the InfiniBand FDR10 network that is used for MPI traffic and also for the file system. Each of these compute nodes, the model exactly is a DX3060M4. It's based with is a dual socket motherboard, in which each of the sockets is based on the SandyBridge processor with 2.6 gigahertz. And you can see it's an 8-core, so we have 16 core without counting hyper-threading nodes. And we have a local hard drive of 500 gigabytes that for supercomputing, for the scalable computing, is just used for a scratch file system, as the operating system is installed through network, but on the VM service is used to have the operating system. We will see later in the description of the VM service that all images of the OpenStack is stored in one of the storages based on parallel file systems. In terms of type of nodes that we have on the cluster, we have different numbering of nodes depending on the number of memories. So we have most of the nodes which have 32 gigabytes per node. So this means 2 gigabytes per core. And then we have 128, which are medium memory nodes, which is 64 gigabytes per core. This means 4 gigabytes, 64 gigabytes per node and 4 gigabytes per core. And then we have another group of 128 nodes, which are high memory nodes with 128 gigabytes per node. So this means 8 gigabytes per core, okay? As I was introducing before, there are two main networks in the cluster, a gigabit Ethernet of 1 and 10 gigabit Ethernet, which is used for management mainly. And we have the InfiniBand network, which is used for parts of the storage and also for the MPI applications. The operating system that we are currently using on the supercomputing part or the supercomputing service is SUSE Distribution 11 SP3, which is very old, and we are doing right now the upgrading these to Red Hat 8. Okay, so this is in our progress task. In terms of software description of the whole infrastructure, we use XCAD software to deploy all the operating systems and managing the internal services. It's an open source tool that is maintained by Lenovo and IBM. And this tool we have configured in the way that we can deploy the operating system to provide the HPC resources or cloud resources. So in terms of dynamically, well, we have to intervene to do this, but we can decide that some compute nodes can be added to the VM service. So we just redeploy the operating system image with the image that is attached to the OpenStack installation, okay? And as I said before, the HPC part, so the scalable computing part, is based on SLS 11 SP3, and we are using LSF as a batch scheduling system. By the idea is that in some months, we will have a RHEL 8, this is a typo, and Slurm as the batch scheduling system. The cloud operating system, so the operating system that we are installing on the compute nodes to serve the VM service, the OpenStack, is based on RHEL 8. And the version that we will offer to users with OpenStack is Train, okay? For the scalable compute service, the access for users is we have 3 login nodes, which are accessible via secure shell from internet. And we have a user manual that it's in this URL. And we have a special team devoted for HPC support that you can contact in this email. But anyway, if a ticket is open through HVP, also it will get directly to the same team. So at the end, it will go to the same people. If we go to the VM service, which is the service that we are working now to be deployed and put in production these days, this is the URL where you can find the dashboard to enter the infrastructure. From there, you can select which will be the different type of authentication methods that we support. So we can, here you can use the Fenix ICEI, you can use the Spanish Supercomputing Network accounts, or you can have a local account based on your BSC account, okay? In case of Fenix, it's clear that the selection will be the one selected in the slide, which is a Fenix OpenID Connect. Once you have logged in successfully, you will get your project. This means that you have been allocated the resources previously. So you will be able to see this type of view with your resources, your instances, virtual machines, and all the things. Also, we have enabled the CLI access through the application credentials. So you could see also the link on OpenStack, how you can create your own application credentials. And in the lower part of the slide, also you can see an example of accessing the OpenStack, the VM service from a shell. Okay. Another item to have in consideration, as I said, the version of OpenStack is trained, and as all the rest of the sites providing resources through Fenix and ICEI, the flavors are the same. And here you have the specifics values that we will have configured for our virtual machine service. So we have the GPP small, medium, large, and X large with the different virtual CPUs that you will be able to configure, and the different RAM sizes and the default disk that you will have assigned by the initially to your VMs. Okay. Here, I don't know if it can be seen correctly. We just show how will be the procedure to create a VM from a CLI from just the beginning, from the starting point. So this is as a test that we achieved just to make sure that all this was working perfectly, and so you can access the service and start creating VMs as soon as you have your account created. So that was most of the information that we had for the Nord infrastructure. As I said, we'll be covering the scalable computing service and the VM service. The other infrastructure that we will have attached to this infrastructure will be the interactive computing cluster. The hardware is based on 3 nodes. 2 of the nodes will have GPUs installed, and we will have 1 without GPUs. Okay, so, and all of them are based on Power 9 processors. And you could see more or less the hardware configuration that we have. So in the GPU enabled nodes, we have 2 Power 9 processors, 16 cores each. We have I think like 1 terabyte of main memory, and we have 2 NVIDIA Teslas V100 GPUs per node. We will have a connection of Ethernet of 25 gigabits, and then we will have 2 operating system images, 2 SSDs that will handle the operating system image, and these nodes will be able to mount the active storage and also the archive storage that I will explain in the next slides. And also we will have a separate compute node without GPUs that for those workloads that doesn't need GPU, and it will use some login type of services in this separated compute node. As I said initially in my presentation, all the resources are completely devoted to Fenix, so these are just open to be used by any of the users requesting resources to us. In terms of software, it's installing, well, it has Red Hat 8.2. We have this version of kernel, which is associated with the Red Hat. It also deployed via XCAT. And we have the different types, this type of versions for the MPI. So we have a special MPI version from IBM. This is the version of the GPFS file system that will be mounted in these nodes, and the version for the CUDA driver and the NVIDIA driver and the CUDA version that will be deployed on those nodes. We will be using a Slurm in case that users need to do execution through batch from the VMs or their services. And also we will use a Slurm as a reservation item in terms that some interactive workload needs to be done. Also the status for the service, Node 3, it's, I didn't mention that, but Node 3 is, as I mentioned, we were upgrading the operating system. VM service is almost ready for production. So we are lacking a change in the configuration so we can open this service to users. Interactive computing cluster, we expecting to have it available in May, because right now we are configuring the servers with all the Slurm and all the software stack. Then the other infrastructure that are part of BSC resources are the storage resources. Both storage resources are more or less in complete production. So this storage, the active storage is 100% in production. It's a 14 petabytes storage that is accessible from the scalable computing and also the interactive nodes. And it's a modular system. It's a modular system based on data modules, which are 7 modules with this configuration. So each module has 2 servers and a set of 6 JBots full of hard drives. And it's using the IBM Elastic Storage service, which provides this RAID functionality that the servers takes care of doing the implementation on of the RAIDs. And each of the modules has 348 8 terabyte drives. And all these modules are providing the 14 petabytes net. Also, the GPFS, it's providing the functionality to separate all the inodes, directory entries in the metadata storage. And this is implemented in 2 modules, which each of them has, again, 2 power servers that are offering this storage. And then we have 2 flash controllers, which are basic SSD or flash storage, in which we are storing all the inodes, directory entries, and the home directories, for instance, for the user are also being stored in SSDs to get better IOPS in the access to the file systems. So as I mentioned, this storage infrastructure is completely in production and is being used not only by the Fenix, but also all the HPC resources at BSC. The other storage infrastructure is the archival storage infrastructure, which is also based in the technology of IBM Elastic Storage Server. So it's also GPFS. Again, we have is a modular solution. In this case, we have 3 modules for data storage based on the GLS6 type of model of the module. And then we have 2 modules for the metadata, which is based in the GS4S model of IBM. Again, we are using hard drive for storing the data. We are using flash SSD to storing the metadata of the file system. And here, and also as a backend for this first layer of storage, which is based on flashing hard drive, we have a tape library with 80 drives and 100 petabytes of storage, which is provided like a second tier of storage to provide all the capacity that the users are requesting. Here you could see more or less a schema of the different components, the different file systems, the library, and also a set of services that I will explain right now. And everything is connected through an Ethernet network of 25 gigabit or 100 gigabit Ethernet per link. As I was explaining in the slide before, we have like a set of servers which is providing different types of services. We have 8 servers that it's used to host virtual machines. These servers will be added to the OpenStack cluster and will be providing a little more memory per host in case that we have a requirement to have a virtual machine with a very huge number of memory. So we will using these nodes for this type of VMs. We also have 8 servers that will be devoted for doing the archiving. So these servers will be doing the movement between the hard drive and the tapes and moving back the data from the tapes to the hard drive, to the first tier of storage. We also have 6 data mover servers that will be holding all the data transfer between the different file systems. So this will be moving data between the active storage, the archive storage in POSIX, and also the archive storage in Swift. Okay, so all these 6 servers will be devoted to all the internal data movement of data between the different file systems. Then we have 4 servers that will be devoted to exporting the archive storage meanwhile through Swift, which will be clearly used by the VM service, and also will be exporting through NFS or Samba to specific services when the user requires a specific access to their data from a specific Windows, for instance, operating system or things like that. Also, we have 2 monitoring servers that just takes care about all the alarming and performance monitoring of the infrastructure, and 2 backup servers that will be handling the backup of the active storage that I was mentioning before. So that was more or less the description of the different resources that BSC will be providing through Fenix. Here in this slide, you could see the different types of access and URLs that you can use in order to request our resources that we hope that will be available or start to be available in 1 or 2 weeks. And as you can see, everything is located in our website. If you are a neuroscientist, you can access through HBP via the Brain's HBP call. So here you have also the link for requesting these calls. And also we have opened the Praise ICEI together call to request our resources.
Okay, there is a first comment. It's a question, Javier, that says, may I ask to give one more time the short description of the archival data repositories? Because the person asking says they didn't get very well the connection between HPC and Swift.
Okay.
If it's possible.
Yeah. So let me go to the slide. Yeah, so the thing is, it's clear that Swift will be accessible through the VM services. That's clear. And what we will have is inside the ICEI, we are developing a research tender that will help to do how we will be moving the Swift objects to the POSIX file systems. And this is being developed right now. And there will be an API that will perform this type of movement. So you can have an object on Swift and you can copy that to a POSIX file system. You will be using the hardware that it's these 6 data movers will be the ones responsible to doing the movement or the implementation of the copy of this data. And at the end, from your account on the HPC, you will see finally the object or the data from the object on your POSIX directory. And as I said, this is being a research development that I think it's being developed right now by the provider, which is IBM. And once we have this working, you will have this functionality and we will report it to all the users.
Javier, so the first question says, can we have an ETA for the different services?
Yeah, that's a good question. So let's start with the ETA. So the OpenStack, we just have to change the configuration on the network to provide the public IPs thing, which is now in some way of configuring, but we have to change it. We are hoping to have this in 1 or 2 weeks, and then we can start publishing the service in itself. This is the VM service. The Swift service, it's we have scheduled the configuration with the provider, which is IBM, at the end of April. So once it's configured, the hardware is there, the storage is there. So the thing is that it will be accessible at the end of April, we are expecting. And at the same time, we are working on configuring. So we have the operating system installed, but we are configuring the Slurm and the software stack on the interactive computing nodes. And also we are expecting end of April to be the date to provide that. But so the idea is the first, in summary, VM service will come in 1 or 2 weeks, and we also expecting in the same term to be able to provide the other services. So that's more or less the time. And
there is on this subject, there is a comment by Sadaf Alam from our partner from the ICEI project that says that ETA across all other Fenix sites is different.
Yeah.
So there is this clarification from Sadaf.
And then another question is if we have users documentation ready to be available for BSC. Yes, I put the link for the current documentation that we have for the scalable computing nodes. And we are also preparing the documentation for the VM service. Here you could see like a simple tutorial, a snapshot of the document that we are preparing. The idea is that we will publish the user guide, the same that you will find in the URL that I have put in the webinar for the scalable computing services. There will be another user manual for the rest of the services, and it will be public in our website. And also I understand that we can also put it on the Fenix website.
So just to conclude, Javier touched upon this already, but this is just another slide on how to gain access to the Fenix services. So we have the Human Brain Project eBrains call that is ongoing, and there's no deadline for this. So neuroscientists across Europe can apply to that at any time. And we also have the PRAISE ICEI calls for proposals that they are published quarterly. And there is actually one call going on at the moment, but the deadline for submissions is today. But there will be another one very soon. Just make sure you check our website for these announcements, and these links will be sent to you also by email after the webinar. So make sure you check this email afterwards. It will include links to all these resources. I wanted to thank our partners for helping to run this webinar series. And we would really appreciate your feedback. So if you could take just a couple of minutes to respond to our survey, Typeform link will open to your browser now, and also it will be sent to you by email. So please just help us improve for our next trainings. That would be very useful for us. And stay tuned. Just make sure you check our website, as I mentioned, our Twitter account. You can send any questions you might have to our email, and you can also sign up for our Fenix User Forum, which is an online platform we created for potential and current Fenix users. So it's a platform for people to discuss any questions they have when they use the infrastructure on Friday afternoon, as Javier said. And yeah, thank you for attending, and thank you, Javier, very much for your presentation.